We are going to start with this one. A car is initially traveling for 50 kilometers per hour. Thus, V initial is 50 kilometers per hour. So we have to convert this to meters per second first. That's what we are supposed to do. We have to convert it to meters per second. So we are going to use the conversion. So the conversion says 50 kilometers, which is per hour. Then we multiply it by, this is another way of just writing any number multiplied by 1. We know there are 1000 meters in 1 kilometer, and there is 1 hour in 60 minutes. So you arrange the meters on the numerator because you want to convert to meters. So we must put the unit, the meter, as a numerator, and then the kilometer will cancel with that one, so that they cancel the units. Okay. 1 hour will cancel with the denominator of this 1 hour. So it's going to be 1 hour over 60 multiplied by. This is another way of writing 1. So we are just multiplying 50 kilometers per hour times 1. But it's just another way of writing times 1. So this is the conversion. There is 1 minute. In 1 minute, there is how many seconds? 60 seconds. So you put the denominator as 60 seconds as seconds. Why? Because you also want the denominator, final answer, to be having a denominator of a second. Okay. So once we are here, then the units, they cancel, the kilometers and the kilometers, they cancel. Then the hours with the hours, they also cancel. Minute and minute, they cancel. Then you'll be left with the numerator, which is 50 multiplied by 1000 meters. Then on the denominator, we only have 60 multiplied by 60 seconds, because the minute and minute, they have cancelled. Okay. Okay. So once we divide, we are going to get 50,000 divided by 3,600 seconds, which is equals to 500 divided by 36. If you just reduce it as a fraction, is 125 divided by 9. Okay. So basically we first divided by 10, then we get this, then we divide again by 4, we get 125 over 9 meters per second. So you can convert it to a decimal if you want to work in decimal, but for this example, I just prefer to work in fractions. Then I just round off in the end. So for now, I just rounded off this one, but I just chose to work with the original one, and then I will round off the final answer at the end. So this is our initial velocity, and this is our final velocity, which is 0. We have been told that until the car stops. So the car has been braking until it stops. So when the car stops, the velocity is 0 meters per second. Okay. And we have been told that the braking distance, it started to apply brakes, and then the braking distance was 35 meters. So this is the displacement. Okay. So basically you can see here we have two variables, which are A and T, acceleration and time, which is unknown. We don't know the acceleration of the vehicle as it was braking, so we call it deceleration because it's braking, it's in the opposite direction. Normally it comes as a negative answer. Okay. So time, we don't know for how long was the braking distance. Okay. So we have two unknowns. So basically this kind of equations whereby you have out of the 5 items of, you are given 3 and then you don't know 2 unknowns. Normally we use simultaneous equations. So we are going to use the equation of motions, which are going to be 2, and then we solve simultaneously because the 2 unknowns and we have 2 equations. Okay, this is what I'm illustrating here. We have two unknowns, which is acceleration and time, and we have two equations here, which is equation 1 and equation 2 of motion. So we know that our velocity is equals to v initial plus acceleration times time. Our final velocity is equals to v initial squared, which is our final velocity squared, v initial squared plus 2a change in x. So it's a matter of plugging in the values and then we solve simultaneously. So the challenge for this kind of problems is solving the simultaneous equations. That is the challenge. But once you get the answer, it's very easy to just come and put the value of a or t and solve for the other variable which is unknown. Okay. So here in this equation, I have just put a sketch of what is happening in this equation, whereby I drew the velocity versus the time graph, and the time is in seconds. So here is the intersection whereby the distance was 35. So we don't know what time it is. We don't know what time it is when the distance was 35. Okay. So what we know is just the initial velocity is 0, and what we know, the v initial was 0, and then the final velocity was, the v initial was 13.89, the final velocity was 0. So we know that when it stopped here, after some time, when this car stopped after some time, the velocity is 0. So to solve the two unknowns, given two equations, we solve simultaneously like I've explained before. So now we are going to explain it simultaneously, how we do it. Right, in this equation we have two equations of motion, equation 1, equation 2. So we are going to substitute the values. Vf is equals to vi plus at, vf squared is equals to vi squared plus 2a change in x. So this is the v initial as a fraction. If you want, you can also convert it to a decimal if you want to work in decimals, but I just did it to avoid the rounding off. I will just round off on the final answer. That's why I chose fractions. So I plug in there, so my plus at, which is this one, at, and then also vf squared, which is 0, is equal to v initial, which is squared, that's your v initial squared, plus 2a plus times the change in x, the displacement, which was 35 meters. So if you multiply 35 times 2, and then 0 is equals to 125 plus a t. So we are just solving the simultaneous equation. Alright, then we just plug in our values. 0 squared is equals to 125 over 9 squared plus 2a times 35. 0 is equals to 125 over 9 plus 80, and then 70a, 2 times 35 give you 70a. And then what happened here? So from this equation, from that equation, what I did was to shift this 80 to the left hand side. If you shift it to the left hand side, it becomes negative. Then you just leave this 125 as it is. Also do likewise, you shift 70a to the other side of the equal sign, it becomes negative 70. And then we are left with 125 over 9 squared, which is here. Okay. So what we are going to do, we want to eliminate. So before we eliminate, like what you normally do, we want to make show that we have AT here, and then we have A. Since we have two variables A and T, we must eliminate one at a time. So the variable which we want to eliminate this time is A. So we want to be left with A on this side, then we can subtract the A's. So what do we do to make this number and this number the same? We multiply equation 1 by 70 over T, so that 70, it will multiply the numerator, and then the T will cancel the T there in the numerator, then we'll be left with negative 70A. The idea is to make sure that we are left with A and A, then at the end we can use elimination by subtraction. After you multiply, that's what we are getting. Minus 70A is equals to 125 over 9 times 70t, which means you multiply both sides by 70t. What you do on the left hand side, you also do on the left hand side, you do on the right hand side. That's an equation. So equation 2, we just take it as it is, which is negative 70a is equals to 125 over 9 everything squared. So this is equation 1. Equation 1, we just combined the two digits, 125 times 70, which is this one. 9 times t becomes the denominator. That's all. Okay, so once we are here, we can see that negative 70 and negative 70, they are now the same. So we want to eliminate these two numbers. If we remove them, then we will only be left with t. Then we can solve for t. So we are going to eliminate by subtraction. Equation 1 minus equation 2. Okay, so let's subtract. Minus 70a minus, then you put a bracket for the whole equation. You are subtracting equation 1 minus equation 2. So similarly, you can see 70, negative 70, negative and a negative will give you a positive. Then it becomes negative 70 plus 70a, 0. 125 times that, 70 over 9 minus that. So 0 is equals to this. So now we are just playing with the algebra only. So we have 0 is equals to 125 times 70 over 9t minus 125 squared over 9. So once we move this to the left hand side, it becomes negative. Okay, so the whole part, we push it to the left, negative is equals to negative, and the negative is still there, it did not move. Okay, so now we want to get rid of 9t. What do? We multiply on the left hand side, and also we multiply on the right hand side. So when you multiply negative 9t on the left hand side, you must also multiply negative 9t on the right hand side. So they cancel. Negative times negative, it's a positive. 125 times 70, that's 125 times 70, is equal to, so for this part, what did we do this side? We multiply both sides by negative 9t on this. So already this part is already there, which is this one. So you multiply negative times negative, give you positive. Okay, so the mistake is when you cancel this 9 and this 9. Remember, this 9, it's a square, so you cannot cancel these two. So that's why I wrote it, this bracket, as two brackets, which is that times that, times this 9 times the t is this one, the t. Okay, and the positive, obviously negative times negative, it becomes positive. So we don't have any negative now. All right, So we continue. We just want to apologize for the load shedding, the darkness. It was load shedding. So 1/9 times, we are here now. So from this step we want to be left with t only. So it's just the algebra. 125/9, you invert it, it becomes 9/125. Because there are two brackets, that's why I squared here. You invert so that they cancel each other. So this 9, how do you eliminate it? By dividing by 9 both sides. 1 divided by 9, this is the 9, that's the 9. If you multiply by 1/9, and also you multiply by 1/9 on the right hand side, you do the same on the left hand side. Okay, then 125 times 70 is this one. Then that is our t, the first bracket, second bracket, all under the square, multiplied by. So what you do on the right, you must also do on the left.